In the previous tutorial, we were able to detect the ledge and edge of a surface, and also we were able to detect if there is something in front of us where we can hook the other end of our webline. If yes, only and only then we will be able to use webline. Otherwise, our webline actor or cable actor will not spawn and we can't use webline. So in this tutorial, we will move our cable or a web line from the origin point to the impact point, so you can actually see the cable moving towards the impact point. So before doing so, we have to rotate our character towards the direction in which we are going to use web line. It is not necessary, but it depends on whatever you want. But if you want to do, you can do it through find look at rotation, and the starting point will be our get actor location, and we want to look in the target, we want to look at the location or impact point, anything you can take, and from there we will set actor rotation. Now let's see if it's working or not. So for example, if we are looking at that direction, okay, it is not working perfectly, I think. Okay, I did a mistake here. We only want to rotate on the your z-axis. It is so the mistake I was doing is there are two line traces, one to detect the origin of our web line and the other the end, and we want to move rotate our character towards the end point. So we have to take a location from there. So that was a mistake. Now it's working fine. So I was doing a silly mistake. Now let's see, is it working? Yes, now. So now our character will automatically rotate in the direction in which we are going to use a web line, but it is not necessary. It depends how you want it to be. So okay, so now our next step will be to increase the length of our cable. For that, it is our BP web line, and we have a cable inside of it, and it is a reference. So we will take a reference here. So we will get a cable component. We will get end location at vector. I'm going to do a little bit of maths here. So if you want to, I will explain here too, but shortly. But if you want to explain, understand it in more details, you have to watch my grappling hook tutorial. I will put a link in the description, and also you will see a link here. So then you will understand more clearly about the maths I'm going to do. So I'm going to do 100, 100 and 100, and this is the direction in which I want to increase the length of the cable. For that, so this is the X, Y and Z. This is the end location, and I'm going to if I want to increase the length of a cable on the x-axis, I have to increase the value. Okay? But so user can use in any direction X, Y and Z. So for that we have to increase in all directions, but we have to apply a limit also. So for that we have to use inverse transform location. It will okay, let's take it. get world transform and our that impact point. This is our final impact point. Okay, that one. This we are taking location of this impact point. So what this node do is it converts the location of that point from world space into local space. So as a end location is in the, as we want to increase the cable length, and end location we want to increase the end location, it is in the local space. So we must have impact point here in the local space. So that's why we are converting the world location of our second impact point or location, impact location, to a local. So from here we need a clamp float node, and we need it 3 times, one for X and one for Y and one for Z. Now we are going to break it. X here, Y here, and Z here. Let me X, oh sorry, Y and Z here. Now good. Now from here I am going to break it also. X at the max limit, Y in there, the max limit, and Z here. And after that we will again take the webline reference here. Now from here we are going to set end location. For once a reminder, if you are confusing here I will explain it, and but still if you want to understand it more clearly, please watch my grappling hook tutorial in which I have explained it very clearly in details. So X will go here, Y will go here, and Z will go here, and we will attach it. Now what it's doing is, when we start cable and spawn our cable, it will start to move in some direction with the incremental value of 100, and right now we don't know in what direction it will move. In what direction our cable will increase its length will depends on that value, because we are converting the impact point and impact point to local space for our web line. Okay, now from here, if it's increasing on the X, we will have a limit there, and if it's increasing on Y, we will have a limit here. So limits are important because we don't want our web line to keep on increasing, but we want to stop the increment of web length when it hits the impact point. That's why I used the clamps here. Now when we press R button, it will increase only once, like I want to show you. So you can see here is our cable, it increased only once, but we want to increase it many times until it reach the impact point. For that we have to make a custom loop here. Event loop web line, and after delay use web line. So now when we will press R, it will keep on increasing until it reach the impact point. Let's see, is it working or not? So I am on the edge of the, so first of all, I am not on the edge. Is it working? No. So now I am on the edge. Now you can see it is working perfectly. It is working fine. Now our web line is moving from that point, and it's going to that point, and it is attached at exactly the impact on the impact point. It's working perfectly now. So let's see, is it working that direction or not? Yes, and perfect. Now because of using that node and that math and limit, we in whatever direction the user wants to use webline, he can use. I want to show you the importance of clamping here. Let me show you. So let's say, okay, now you can see our web line stopped at the impact point. It's not increasing further. If we don't use clamp, then it will keep on increasing infinitely. So the use of clamp here is must. So now we have our working web line. Now the other thing we can do is to add a flexibility and a little sag here. We can do it by increasing the actual length of the cable. I want to show you how it actually works. So let me increase. Okay, let me increase. Now its length is 400. Let's make it 400. Now our cable length is 0, so it's kind of stretchy and stiff. Now if I increase the length, now you can see now you can see it is less flexible, it is more or less, and if I move towards 400, it is going to be more loose and flexible now. So it depends on you how much value you want here. Now we are going to make a little sag here only if you want. If you don't want, then you don't need that. So how we are going to do it? Make vector x, y, and z. Vector length, and now we are going to plug it into set cable length. First here and then here. But now before that we have to multiply it by some factor here. Let me multiply it by 1.03 or any value, and let me use set loop here. Now let's see how it goes. Now you can see we have a very flexible web line. We can decrease the value from here. Let's say we're using 0.5 here. Now it is less flexible now. Okay. Now I can make it more like 0.3. Yes, now I think it's perfect for me. Now from that factor you can control the flexibility and the looseness and stiffness of the cable. Now it's looking bit bad as it's increasing very slowly further. For that we have to decrease our delay here. Yes, perfect. Now as soon as we move it quickly, you can see a little flexible movement of a web line like it actually happens in the Spiderman. So I've done a little mistake here. For the cable length, instead of multiplication, we have to use division because we have to control some values here at the web line later. So please correct that, and you can increase or decrease that value to increase or decrease the flexibility, looseness and stiffness of the cable like we did it with the multiplication. In the next tutorial, I will make that character to walk on that web line. Right now there is no collision on the cable, and to make a collision on the cable, in order to make our character and to walk or make that cable walkable, we have to do a little bit of work. So that's why I'm going to make it in another tutorial. So till the next tutorial, Allah Hafiz.